So now we're going to take a look at example number 12. So in this question, the diagram shows that the shaded region, which is bounded by the curve 2y equals x plus 3 and also y equals square root 4x. So the question asks us to find the intersection points between the two curves and find the area of the shaded region. So first of all, what we need to do is we need to find the intersection points. What we have is the first equation given to us is 2y equals x plus 3, and the second curve equation is y equals square root 4x. So to find the points of intersection, we would need to substitute 2 into 1. So what we'll get is, to get rid of the square root, we will be squaring both sides. So this gives you which simplifies further to be so x is equals to 1 and x is equals to 9. So to find the y coordinate of the intersection points, we will substitute x equals 1 into one of the curve function. Therefore, the intersection points are at 1, 2, and 9, 6. So we have answered A. Now, how do we find the area of the shaded region? So now we could label our intersection points on the graph. So this would be 1 and this would be 9. So now, by looking at the graph carefully, we could actually identify that we could use the formula integrating from the interval a to b. We take the upper function minus it with the lower function and integrate it with respect to x. So in our case here, our interval would be from 1 to 9, and our upper function, so this is the shaded region. Okay, so we want to find the area of this region. So the upper function would be the one on top of this region, which is the function y equals square root 4x. So we'll get 4x minus the lower function, and the lower function would be 2y equals x plus 3, y equals x over 2 plus 3 over 2. So we could write it this way, x over 2 plus 3 over 2. The whole thing, integrate it with respect to x. So the first bracket gives you 9 over 4 minus the second bracket. Second bracket gives you 5 over 12. Therefore, Minus means minus, we add them together, becomes 8 over 3 unit squared. So this will be the area of the shaded region. In this example, we are going to find the points of intersection of the curve and the straight line y equals 13x plus 1, and on the same coordinate axis, we are asked to sketch the curve and the straight line. And then we are asked to show that the area of the region bounded by the curve and the straight line is 407 over 4 units squared. So first thing first, we need to find the points of intersection. So whenever we need to find the points of intersection, you would need to equate both equations together. We're now going to equate equation 1 with equation 2. We then solve to find the value of x. So now we have three values of x. We need to substitute the values of x we got into the equation. Our intersection points are at point 227, point -5, -64, and point 0, 1. And now, if we were to sketch the curve and the straight line, it will look like this. The curve will have y-intercept at 1, and the curve will have x-intercept at -1. So your curve will look like this. And now, let us draw a straight line. This straight line will have a y-intercept at 1. So this straight line here will be our line y equals 13x plus 1. So now, let us mark the area bounded by the curve and the straight line. And so, this is your straight line, and this is your curve. So, the two areas that has its borders highlighted is this one right here and this one right here. So an additional information which will be helping us in showing the area of the region bounded by the curve and the straight line will be the points of intersection which we have already found. So this will be equals to 2, and this will be equals to -5. So how are we going to show the area of the region bounded by the curve and the straight line is equals to 407 over 4 units squared? So we are going to do like what we have done previously. We are going to separate it into two parts. So we'll label area 1 and also area 2. So when we add them up, we'll get and show that it's equals to 407 over 4 units squared. So now if we were to look closely at area 1, actually take the integral between 0 to 2 and we take the upper function minus the lower function. So we'll obtain the value of the area. So now let us compute. We take the upper function minus the lower function, integrate with respect to x. So what we'll get is area 1 is equals to integral from 0 to 2, upper function which is 13x plus 1 minus our lower function x plus 1 to the power of 3, and we'll be integrating the whole thing with respect to x. And then it becomes pay a little bit more attention to the minus here. When you open up the bracket, make sure you consider the minus. You simplify further, you'll get and now you'll be integrating it with respect to x. For the first bracket, you'll be getting, and for the second bracket, you'll be getting 0. So this will give you, so this will be the area for the first part. So now we're going to find the area for the second part, and then we're going to add both areas together and show that it is equals to 407 over 4 units squared. So now let us take a look at the second area which we are going to calculate. If you were to see and look at it carefully, you can see that we could also solve and calculate the area by using the formula upper function minus the lower function, and we integrate with respect to x in the interval -5 to 0. So what we're going to do, we are going to use our formula. We're going to use the upper function minus the lower function formula. So our upper function is the y equals x plus 1 cubed, and our lower function will be y equals 13x plus 1. So this is the upper function and this is the lower function. So our interval will be from -5 to 0, and our upper function, as said just now, will be x plus 1 to the power of 3 minus 13x plus 1, and we'll integrate with respect to x. So now we're going to simplify our integral and solve to find the area. We would need to expand when you open the bracket and when it has minus in front, please be extra careful. So minus meets plus will become minus, and minus meets plus will become minus. That is why we get minus 13x minus 1. So now we simplify further, we'll get I think I'm going to stop for a few seconds to let you calculate by yourself, and we'll compare our answers. Okay, so let us compare our answers. So the first bracket will give you 0, and the second bracket gives you minus 375 over 4, and so it's 375 over 4 unit squared. So now we have already found area 1, the first part, and area 2, the second part. So now to find the total area and to show that the total area is 407 over 4 units squared, we would need to add both areas up. Previously, we have calculated that area 1 is equals to 8 units squared. And area 2, we have just calculated 375 over 4 units squared. So the total area is going to be area 1 plus area 2, 8 units squared plus 375 over 4 units squared, and this gives you 407 over 4 units squared. And that's it, we have already shown. So that is how you find the area of the region bounded by the two curves.